Okay, so when it comes to these pieces back here, again, I don't want them rotating into this geometry. So I'm going to use a volume to mask off where the dampening can happen. And then we'll use the same exact trick that we did here by multiplying against the orient values and preventing them from rotating. So in doing this, let's go ahead and create a box. I've already taken the time to make a box this size. I turn it into a fog volume, which we can see better if we change the viewport right here. And now in this volume wrangle, we need to use the function relative bounding box to get information which will allow us to create a ramp in masking these volumes off. So if you're not familiar with the relative bounding box function, what it basically does is this. Say that I have a box. Well, let's just take a copy of our box right here. And I use a point wrangle. What this will do, if we say rel bbox, is it'll create values between 0 and 1 on a certain axis that you specify. So press F1, see what ingredients we need first. This will make sense here in a minute if you don't know. We start with the current geometry stream and we simply use position. Now, the key here is that we need to specify some sort of axis on that position. So if we do the square brackets after this, let's say in the x direction, so that's going to be the index of 0. And we set this to color, so at CD is equal to this. We'll be able to visually see this gradient occurring. So now over here on the left-hand side, that's negative. In the negative direction, that is now a value of 0. As we go to the right, that is a value of 1. And just to really visualize this, say that I want to see what color is, those values. I can say CD, and you could see that we have 0 to 1. And every value in between as well. So there we go. Now, the idea again is that we take these values, we're doing the same exact thing, except now we're going to cut into density. So the way this works is that we need to create a variable. I'll call this density falloff. And that's going to equal to, for right now, let's just say relative bounding box 0 at position. And let's take this in the z direction. So we'll do an index of 2. If we do that, and then we say, all right, now density is equal to, let's say this density fall off for right now, we end up with that. So the density gets lessened over here, and over here we have that. Okay, so that's pretty sweet, but what if we want to change these values with a ramp? And we do. Well, we can use the channel ramp, so ch ramp. This is going to take a string for the name to start. So we'll say the channel here is going to be called density ramp. And the second argument is going to be the ramp position, which is our density fall off that we just made. Let's create that parameter. And now we have this to play with. So as I bring this over, I'm changing where that value of 0 occurs. And that's really good. That value of 0 is eventually going to become that which we multiply against the orient. So anything that's 0 is not going to rotate anything. Anything that's kind of an in-between value, as you can imagine, will be somewhere in between. So let's say that we don't want anything happening until right there. We do want the full rotation leading up to that, though. So we'll do something maybe right around there to start. And that's going to be a great mask for us to work with. Now we do have this SOP, which is called attribute from volume, that I've used before. And that will take these attribute values and send it over to some sort of attributes that we can use in SOPs. However, there's a much, much more efficient way of doing this. This is going to slow down the network considerably. Instead, you want to use a point wrangle to sample these values and then use that to apply it to information that's on the points. So let's just copy this whole thing real quick. We'll paste it in here. Okay, so we'll do that to start. The only difference, though, is that we want to sample from this volume. So that's going to go in the second input right here. And what I'll say is that we take this orient multiplier, and instead of looking at the channel that we specify, we're going to use a volume sample. And this is very easy. All you need to say is, all right, look at the second input on the node, look for a field called density, and I believe we need position. Let's double check on that. So yeah, we need position as the last argument. So I believe this is what we need now. And let's see what that did to our pieces. So let's go forward a few frames here. See when we have rotation occurring. And sure enough, it works just fine. The areas over here are not affected. We only have the areas right here, and that's awesome. Okay, so taking this same idea, we can now use these volume ramps to mask any sort of effect we want. As an example, let's say I don't want to scatter as many points back here. Well, I could take the same exact trick. I can literally just take this and copy paste it up here. And I can use that to, let's say, multiply against the volume that's responsible for the initial scattering of the points. So we have, again, this box. I don't want to scatter and Boolean anything, let's say, over here. And now I can do the same exact thing over here. Let's use a volume wrangle, and I'll simply say, let's create a variable. It's a float value, vol mults. That's equal to volume sample. Go through index number 1. It's called density, and use the current position. We're taking that whole thing against surface, and we are saying times equals vol mult. And the reason why I'm using surface is because if we middle mouse here, you'll see that the VDB is called surface by default. Okay, so that multiplies against this. We can't really tell what's happening yet, though. Just to see if this is working, though, we can just take this ramp over and see what happens when we do that. So yeah, it is in fact working, which is awesome. Okay, so we have that all going pretty well. Let's also copy paste this compile begin and end just to keep everything nice and clean. We don't need them really happening with all this stuff. We can just have them occur afterwards. So we can just do that, and that is perfectly fine and acceptable. So that takes care of our compiled stuff. And just to see what this does at the end of the day, let's go ahead and take this whole thing, plug it into the end, and just double check that it works. Sure enough, it does. And now when we go to scatter our points, we can save on all of this information, which we don't want to calculate. So that's awesome. There's one more trick up my sleeve for masking this off. Let's say that we have our camera, and I want to get rid of any voxel that the camera can't see. So all this stuff on the sides. Well, we have a volume SOP that we can use to create a volume based on the camera. So you say from camera, render cam, initial value is 1 for the density. Let's call this our cam mask. Let's go ahead and put the visibility there. Uniform sampling divs, 200, and then take out the Z far. Look at that. Now we have a volume for our camera. That's awesome. Convert that to a VDB. And then from here, we can use a VDB combine to multiply these two guys together. So we do that, multiply. And we're almost there. We actually want some padding because we don't want to go exactly to the edge of the camera. So on this volume, the window X, let's say negative 0.05, 1.05, and then likewise for the Y. So we'll do something like that. And this will give us a much better result. Just to double check these values, let's use a volume slice. Volume slice. And then we can see that these are the values that that volume is giving us. And it looks really good. I'll go ahead and set a couple nulls here because this mask is going to be useful for all kinds of things in the future. And we don't want to recalculate this stuff. So let's say that this is our mask with fall off out. And then we'll just say this is our camera mask right here. Because sometimes I don't want that fall off going back. So we'll say mask without fall off. And I guess I should do this as capital letters too. But anyway, that is what's going on there, guys. I hope that helps. This is amazing for all kinds of things, and I'll see you in the next video.